Welcome to this video. Today we want to discuss about a problem which are assigned in the internal assignment. Okay, the problem is says that the electric field and the magnetic field of a moving charge particle in SI unit are this. This is the electric field and the corresponding magnetic field is that. The corresponding magnetic field respectively. There are the usual notation like beta is the velocity speed by c, and like that. E is the electric field, b is the magnetic field. Find the electric field and magnetic field for the rest point charge and the uniform moving charge. This is a accelerated particle. These expression are for accelerated particle, accelerated moving particle. This is moving charge particle is accelerated or non-uniform accelerated accelerated moving charge. Why? Because there is a term of beta dot. Beta dot is the velocity. Beta dot is nothing but the time derivative of beta. So this is the term of acceleration, right? So we need to find out the electric field and magnetic field for the rest point charge, and as the for uniform point charge, that is for beta dot equals to 0 in this case, right? And the question says that draw the four corresponding field lines obtained above. The magnetic field and electric field obtained in this case 1 and in case 2, we need to draw out these field lines of electric field and magnetic field. So in case 1, the rest point charge, rest means the velocity term is 0, speed this is nothing but v by c. So this must be 0, and the beta dot, since velocity is 0 and the corresponding the dot is also 0, derivative of time is 0 is 0. So if we put the beta value 0 and beta dot 0 in this expression, we get is this value 0, this value 0, we get only r cap by r square term, and this term also be 0 because there is a multiplication of beta dot. So we get only q by 4 pi epsilon naught r vector by r q or r cap by r square, right? And the corresponding b is 0 because the this is r cap, b is equal to nothing but r cap cross e vector, and this is nothing but q r cap by 4 pi epsilon naught r square. So r cap cross product also 0. So magnetic field is 0 and electric field is like that for rest point charge particle. Now comes into the uniform moving charge particle. For uniform moving charge particle, the acceleration term must be 0. So if we put the acceleration term in 0, this term is 0, and this corresponding term is expressed like that. And after just calculating these two term, that is r u vector and r dot u, and rearrange them, you get this expression, and just put this, you get the value of electric field. Okay, so this is a mathematical jugglery. You need to find out the mathematical jugglery to find a simplified form of this electric field like that. Okay, in this expression you can say this term, this beta square sine square theta is important term, and this term is increasing in the perpendicular direction and decreasing or reduce in the parallel direction. That's mean this electric field in the, this is the motion of the particle. If this is the motion of the particle, the electric field density increase in the perpendicular direction and decrease in the parallel direction. Okay, and the corresponding magnetic field, just use this relation, you get the, using this electric field, you get the value of the magnetic field like that. Okay, so you need to this is the electric field and magnetic field of this expression, we obtain this value, we get the electric field and magnetic field for rest charge and the uniform charge particle. Now we need to draw the four corresponding field lines of the above case. So in this case, the electric field, you can say this is the radially outward and magnetic field is 0. So the draw, electric field is like that. So this is the electric field lines. If charge is positive, this is outward, otherwise is what in inward. So this is the electric field, this is the electric field, this is the electric field, right? And you case of uniform velocity, that is acceleration is 0, beta dot is 0 for this case. In this case, you can you see that the, this is the direction of the particle and this is the perpendicular direction. You see that in this perpendicular direction, density of the electric field is higher compared to the parallel direction. This is the parallel direction and this is the perpendicular direction, this is the perpendicular direction and this is the parallel direction. In perpendicular direction, this is denser than compared to the parallel direction. And the corresponding magnetic field of that, this is the magnetic field is like that. Okay, this is a this is a particle and moving in this particle, this is the magnetic field is larger, and in the both side there is a circular magnetic field with reducing the radius. Okay, and for that the magnetic field is 0. So this is the point of this particle for the magnetic field. Okay, I think clear all about this. So thank you, and this is all about me. This is my contact details. Thank you.